Think we are live. Think we are indeed live. Anyone is in. I'm full screen for now. If anyone wants to look at the question. Guys, just get my TikTok live going, just to notify people, promote the stream if I can. Let me know how everyone's feeling for paper two. Let me know how everyone is feeling for paper two. Alright guys, just set up a TikTok live. Gonna be doing mainly stats. I kind of want to give a little summary of all these rigid bodies questions as well at the end. So that's what we're gonna do today. A lot of stats. I already got the first question up if you guys want to have a go. But just get the TikTok live up, making sure it's all good. Alright, perfect. Alright, boys. Statistics and mechanics, your final maths exam. A-level maths paper 3. We are almost done, guys. Almost done. Pax is already here. Heard you were playing me out loud at your doctor's appointment or something. Appreciate that. I hope these are helping, guys. I do really hope that these videos are helping. I'm just gonna try and see what I can do here. Mechanics. Do we prefer mechanics or do we prefer statistics? I did a mechanics stream earlier today, so if you're more interested in mechanics, watch the recording of that. We will be doing a little bit of mechanics there. I have a tough question on mechanics. Well, I'd say two tough questions. You have to remember with these static rigid bodies, the questions do tend to repeat ourselves, but it's always the same idea. We're going to take moments about a certain point to eliminate some forces, resolve vertically, resolve horizontally. Lol, I had to learn the question you made. It makes so much sense. I hope that makes sense. Yeah, Chem Paper 3 is still lurking around. That is very true. Chem Paper 3 is the day after, which is disgusting. I'm not going to be doing a live stream for Chem Paper 3. I will be making probably some Paper 1 videos because I assume the organic stuff is quite fresh. We'll get started in 3 minutes time, guys. In 3 minutes time, we'll get started. Yeah, Pax, I'm gonna go over like all the rigid body like possible things to understand the reaction forces. The key thing you have to remember with rigid bodies is if you have that rough wall, we know there's going to be friction on the wall, right? If you have a hinge implies that there is going to be that vertical component as well, right? So essentially, if you have a hinge, the question won't involve a rough wall because that hinge is already producing the forces. But if you do have if there's no hinge, like we saw a previous question earlier, let me just go to question we did earlier. We're gonna do that hinge question today, the one that I just had up. But the question we had earlier with this one, you can actually see there is no. If I quickly check, there is actually no hinge at point A. If I just zoom in, there's no hinge at point A. It just says it's attached roughly to the wall, right? So because there's no hinge, all we have to consider is that friction, which is in this case holding it upwards, I believe. Could be downwards. Once again, it doesn't matter whether we put it up or down, just depending whether we get a negative answer. That will tell us whether we put it in the right direction. Is that in the live before or this live? This question was in the live before. Hinges are nice. This question was in the live before. We are going to be going over a hinge question and a ladder question anyway, because I know this is what people want. People want this rigid body stuff. But for now, we're going to do statistics. We're going to start with stats. Yeah, so I'm going to leave this question up, guys. We're going to start with a bit of binomial, critical region, bit of normal approximation, all in one question. Feel free to have a go. Just going to make sure the stream quality is okay because my laptop is already quite warm. So fine, boys. I'm trying to hit 300 subscribers. That's the goal. If we can hit 300, I'll be over the moon. We're close. We're close. Yeah. So this morning we did mechanics. Today is predominant. Like I'd say we're mainly going to do some stats today, but there are some very good points about rigid bodies. One more minute, then we'll get started. Oscar's back for round two. Learn maths of his 12-hour live stream. Definitely quite impressive. Definitely quite impressive. I would say like doing a 12-hour stream is the one thing I noticed. I clicked on it. I was curious. He has to like pace himself. He definitely had to stay calm for a lot of the time. He was struggling. All right, let's go, boys. Let's go. All right. So here we have binomial, critical region, bit normal approximation. Let's get started. Make sure the TikTok live is working. Boys, yeah, last maths paper. Okay. So let me just make sure you guys can see it all. Okay. The records in a dentist surgery show that 15% of patients that make an appointment fail to turn up. So we have a probability already, 0.15. A fixed probability. I'm already thinking binomial. And of course, I lived in binomial, but I'm already thinking binomial. In a day with 15 appointments, determine the probability. So 15 appointments, we have n trials. That exactly two patients fail to turn up. and that at least two patients will fail to turn up. So exactly two, when it's an exact number, we're going to be using binomial PD. So what we're going to do first, define it. So X is going to be the number of patients who fail to turn up. So to fail to turn up, we have 15 trials, 15 appointments, and we have a fixed probability of 0.15, 15%. So binomial PD first in your calculator, we want. So once again, X binomially distributed, 15 trials, 0.15% of them not showing up, or success, I guess, each time. Probability X equals 2, PD, N equals 15, X equals 2, probability 0.15. It gives you 0.286. I'm not going to waste your time with these questions. At least two patients will fail to turn up. So we're saying, so X is our number of patients who fail to turn up. We're saying that at least two. So X can be two or more. So the probability that X is greater than or equal to 2 is 1 minus the probability that X is less than or equal to 1. So you plug in this into your calculator with your same N, same probability. So you do 1 minus 0.3186. That's a probability X is less than or equal to 1. This is binomial CD because it's cumulative. It includes X equals 1 and X equals 0. And that will be equal to 0.6814. Very simple, part A, quick marks, okay? Ignore these number of marks, guys, as well. Like, this is not accurate. Use a distributional approximation. In your exam, it should say normal approximation to find the probability that in a month with 400 appointments, okay, so this time our number of appointments is 400, more than 45, but at most 65 patients will fail to turn up. So first things first, let's convert from our binomial to our normal. Guys, what do we have to do besides changing the mean besides finding the mean and finding the variance? What do we have to do when we go from a binomial distribution to a normal distribution? We're going from discrete to, let me put it in the chat, guys. I'm going to quickly walk through about converting to find the mean and the variance. So to find the mean and the variance, we have our formula. It's in the formula sheet. I already put it up here, guys. I hope you guys wrote it in already. So what do we want? We want the probability that X is larger than 45, going back up, because we're saying it has to be more than 45, but at most 65. So we include 65, we don't include 45. So X must be larger than 45 or less than or equal to 65. So this is the probability, just changing our 45 to be less than or equal to. This will be perfect, guys. This is the probability that X is larger than or equal to 46, less than or equal to 65. As we know, we're going to define Y now to be our normal random variable that we're going to apply this conversion or the normal approximation to. So Y is normally distributed, N times P, our number of trials, times our probability. Now the number of trials is 400. The probability of a patient not turning up is still 0.15, so that stays the same. And then our variance will be N times P times 1 minus P. So for the mean, we do 400 times 0.15, the mean is 60. And then for our variance, guys, not the standard deviation, the variance is 400 times 0.15, then 1 minus P times 0.85. So we get a variance of 51. So now we have our normal approximation to be Y is normally distributed with a mean of 60 and a variance of 51. When we go binomial to normal, we're going from a discrete random variable to a continuous random variable. WAG's got it straight away, continuity correction, right? So we currently have probability that X is larger than or equal to 46 or less than or equal to 65. So what we're thinking for the continuity correction, well, we currently have this. For our normal approximation, if we want to be larger than or equal to 46, we have to be larger than anything that would round to 46. What would round to 46? 46, the smallest number that would round to 46 would be 45.5. So we have to be larger than 45.5, then to be less than or equal to 65, we're going to be less than anything that we have to be less than anything that can round down to 65, right? So it'll be less than 65.5, because anything over 65.5 we round to 66, and that would already be outside of our range, okay? So all we have to do now is we have our standard deviation to be root 51. Remember, we take the square root of the variance for the standard deviation, and our mean will be 60. In this case, it's just normal CD. This is our lower, this is our upper. Normal CD, we got the standard deviation, we got the mean. This just gives us 0.7582. Nothing scary there, guys. Nothing scary, nothing scary. I guess the key thing you have to spot is we're doing 400 appointments now. So you change your number of trials, but other than that, nothing bad. Continuity correction, be careful. Think about your rounding or rounds to 65 or rounds to 45, all that stuff. That's it. So the surgery administrator feels that the percentage of patients that make an appointment fail to turn up. Sorry, my hay fever is killing me, guys. And fail to turn up is likely to change in the future. The surgery tries an automated system of generating message reminders on patients' mobile phones. Okay, it's required to find whether the proportion of patients that fail to turn up is different from 15% by monitoring the next 20 appointments. Determine the critical region for this test at the 10% significance level. Guys, one-tailed or two-tailed? So hypothesis test, one-tailed or two-tailed? So she feels the percentage of patients will change. So it's not going to be 15% anymore. It's going to be something else, right? Pack's already up, straight on it. It's two-tailed, guys. Why is it two-tailed? Because we're saying change. She's not saying it's going to increase. She's not saying it's going to decrease. So what we have to do is we're going to split our 10% significance level into the lower tail and the upper tail. So we're going to designate 0.05 probability or 5% to both the lower tail and the upper tail. Yeah, you guys are all calm. Perfect. Yeah. So we designate 5% to each tail. Perfect. So what we have to do, this is a bit of a calculated game here. You plug in certain values, seeing when you get a value that is so extreme that it's less than 5% chance of it happening. Yeah, 5%, two-tailed, 0.05 at each end. So let's do that. Bit of calculator work. We're determining the critical region. Values that are too extreme given our current distribution. Current distribution, we have the probability of 0.15 and we have the trials to be 20 appointments. Yeah, this is binomial. Yeah, this is binomial. Because it's 20 and we still have that fixed probability. We have a fixed number of trials, fixed probability, and independent trials. Each appointment is not reliant on previous ones. So that's what we do, guys. Now this time X is binomially distributed, 20 trials, 0.15. This is not a sample, guys, it's just 20 trials. We're not telling us it's a sample mean, it's just 20 trials, okay? Our null hypothesis is that the probability is 0.15. We're asking, is this going to change in the future? So the alternative is the probability is not 1.5, two-tailed. Critical region is 10%, 5% at each tail because it's two-tailed. Plug the values into your calculator in order to find the critical region. We need the probability to be less than 0.05 on each end, okay? So with our lower tail, we plug in some values. So using that n equals 20, p equals 0.15, use your CD, binomial CD, because it's less than or equal to. In this case, you could put equal to because 0 is just 0. There's nothing less than 0 in terms of people who fail up to turn to appointments. But either way, you plug in 0, you get 0.0387595. This is less than 9.95, sorry, 0.05. So this is in our critical region. This probability is less than 0.05, so it's in the critical region. So this value is too extreme given our current distribution. Given the current probability, this would make us think, okay, maybe the probability is a little bit less, okay? So then we have, plugging in 1, we have a probability that x is less than or equal to 1. This will be equal to 0.175559. This is larger than 0.05, so this probability is not small enough. We would actually potentially expect to see one person or only one person not turning up because we get a probability larger than 0.05. So this is not our critical region. If the p is low, reject the hoe. Yeah. Upper tail. So this time we're going to see the larger than side. Check the probability x is larger than or equal to 6, for example. Obviously, I've prepared this so I know what numbers to put in. You got to be careful. So probability x is larger than or equal to 6. 1 minus the probability x is less than or equal to 5. Got to know this. So that's 1 minus 0.93269. This gives us 0.0673. This probability is larger than 0.05, so it's still viable given our significance level. Yeah, it's not extreme enough to be like, okay, wait a minute. The probability x is larger than or equal to 7. Try 7 now. More extreme. Equals 1 minus the probability x is less than or equal to 6. If you put this probability x is less than or equal to 6 using your binomial CD, number of trials 20, probability is 0.15, you get 0.978. 1 minus this will give us 0.0219. This is now, I don't know what the list method is, but this is easier. Okay, yeah, so this gives you 0.0219, which is less than 0.05, so this would be in the critical region. So our critical region is either x is less than or equal to 0, the lower tail, or x is larger than or equal to 7. So these are the values. If we see this number of patients not turning up, I believe, then we would think, okay, cool, the probability is going to be wrong here, whether it be lower or higher. Okay, oh yeah, okay, part D. Still one more part, guys. Basically the same kind of question. Write down the critical region for the same test if the probability of rejecting at either tail is as close as possible to 5%. So in this time, we're not saying it has to be less than 5%, we're just saying it needs to be close to 5%. So what we do is take the exact same answers that we had before. So as close as possible to 0.05. Look at from above. Oh, yeah, sorry. Use your answers from above, sorry. So looking at probability x is less than or equal to 0, is the 0.0387595, then the probability that x is less than or equal to 1 is 0.1755579. Which one's closer to 0.05? It is indeed the probability that x is less than or equal to 0, so this remains in our critical region. However, looking at the upper tail from before, we had our 0.0673 for the probability that x is larger than or equal to 6, and then 7 was actually 0.0219. Okay, which of these are closer to 0.05? If you can't do it in your head, you can always plug it in your calculator. It would be this probability that x is larger than or equal to 6. So our critical region this time will be x is equal to 0 or x is larger than or equal to 6. Okay, so it does change when you want closer to. And guys, if you wanted your actual significance level, sometimes they ask that as well. All you'd have to do is add these two probabilities in this case. If you took this critical region, you'd add your 0.0673 to your 0.0388. We can actually see what that would be. I believe my calculator should be here. Not sure where it is. I thought it was here. But yeah, that's about it. I might just grab my calculator, guys. Just give me 30 seconds. I'll put on the next question up if you guys want to have a look at it. Here's the next question. I'm just going to grab my calculator. 1 second, guys. Let's try and find it. Alright, boys. Just in case I want to check some numbers, we do have the calculator. Right, I'm going to go for the next question now, guys. I'm going to make sure the streams are all running. All good, all good. Looks like we're all good. Perfect. Okay. So next question is a little bit of potentially tree diagrams. I'm going to show you don't have to use a tree diagram. So we have a scheduled flight DM104104 of a certain airline can be delayed due to the following reasons. We can either have aircraft technical problems denoted by the event T, weather conditions denoted by W, and air traffic congestion denoted by the event C. These events are assumed to be independent of one another, and the flight will be delayed if one or more of these events occur. So if we get any of these events, it's delayed. So we only need one of them to be delayed. So it's given that the probability of technical problems T is 0.1, weather conditions is 0.05, and traffic congestion is 0.2. Probability of C is 0.2. Find the probability that the next flight, DM104 flight, will be delayed due to exactly one reason. Exactly one reason, guys. So if you want, guys, you could draw out your tree diagram. Me personally, I think that's a little bit long. Maybe you should in the exam, but I think it's a bit slow. So the best way to do it is because we have three possibilities of T, W, and C, or not T, not W, and not C. Each of these can either be not T, or not W, or W, right? It doesn't matter the order, they're all independent. So it's not like they happen sequentially, it's just about if they happen at all, right? So if you wanted to draw out your tree diagram, you could draw it out like this, guys. This would be your tree diagram. Each of these probabilities remain the same. To get the probability that one doesn't happen, you just do 1 minus the probability that it happens. But I'm going to show you a faster way potentially. So the first question they asked us, the probability that we will be delayed due to exactly one reason. So what we can do is list out just T's, W's, and C's, and not T's and not W's and not C's in different combinations to see the times, or the cases where only one of them would cause a delay to the flight, or where only one of them would be present, essentially. I didn't articulate that very well, but I'll walk through it. So we have a probability at the top here. All the ways that we can get delay, given only one of them happens, would be T, W dash C dash, T dash, W C dash, or T dash, W dash, and C. So each of these have not for two of them, and yes for one of them. Okay? So only one reason, guys. Only one reason. So all we have to do from here is for whichever one doesn't have the not on it, we just times it by that probability given. So for T, W dash, C dash, it's going to be 0.1, 1 minus 0.05, 0.95, 1 minus 0.2 is 0.8. And we do this for each one, guys. So 0.1 times 0.95 times 0.8, 19 over 250. No T, yes W, no C, 0.9, 0.05, 0.8. Just doing the 1 minuses and then plugging in the probability they give us. You can also have T dash, W dash, and C. So each of these only have one of the problems that causes delays. This would be 0.9, 0.95, and then we do have this congestion that's going to be 0.2. So we have 171 over 1,000. add them all together to get a total probability for one reason. So each of these do satisfy a condition for one reason causing a delay. Add them all together gives you 0.283. Okay, nothing scary on this one. Let's um let's move to the next. And the reason we don't care about the different orders, like T dash, C, W dash, because it's all the same thing. It's all the same thing. We won't have, was it traffic or weather? Was it, sorry, technical conditions or something like that? Either way, we won't have T, we won't have W, and we will have C. They're all independent. There is no order based. It's not like when we're replacing colored balls, whereas like, okay, we care whether we've taken this one first and we need to change the denominator and the numerator. In this case, it doesn't matter. However, if it's something like picking colored balls out of a bag, it does matter what we took first because then our probabilities will change. This is not the case here. They are independent. So exactly that, A intersection B is the same as B intersection A. So next bit was the probability that it will be delayed. So be delayed, there's a lot of different ways it can be delayed. However, there is only one way that we see no delay. Okay? The only way that we see no delay, so that's exactly what we can do. So the probability of delay is 1 minus the probability of not delayed. The only way it won't be delayed is if we don't have any of these problems. So we have W, or not T, not W, and not C. Do you guys all say complement? Like, for me, it's T complement, W complement, C complement. I feel like not is what most people say in A level, right? Okay, so we do 1 minus the probability of not delayed. So it's 1 minus the probability of T dash W dash C dash, or not T, not W, not C. This will just be 1 minus all of our given probabilities. So we're going to have 0.9 times 0.95 times 0.8. This will give you 0.684. So the probability of delay, any delay, with any of these combinations that aren't, none of them happening, be 1 minus 0.684 to get 0.316. Hope that makes sense, guys. Hope that makes sense. So given that the next DM104 flight was delayed, so we have a condition, guys. Conditional probability is going to be used. Find the probability that it was delayed due to one reason only. One reason only. Okay, let's go. So a conditional probability, what are we asking? We're asking the probability that one reason caused the delay given delay. We know the probability of A given B is the probability of A and B over the probability of B. So we have the probability of one reason causing the delay and the delay over the probability of delay. However, looking at the numerator, the probability of one reason causing a delay and delay, well, if we have one reason causing a delay, this is already going to be a delay. So that's already the same thing. All we need is a probability that one reason caused a delay, and that's enough. And that'll be over the probability of delay. We have these probabilities already. The probability of delay is 0.316, and for one reason is 0.283. So simply we have 0.283 divided by 0.316 to get 0.896. Pretty simple conditional probability using your answer to part A. Hope that's all making sense. Let me know if it's too easy, guys. I have a lot harder questions coming. I will say that. A lot harder questions. Horrible probability distribution table coming up later. That's not a nice question. Okay. So given that the next DM104 flight had no technical problems, so given that there were no technical problems, find the probability that was delayed. Okay? So the probability of delay given not t, okay? Not t. So you know the probability of not t is 0.9, 1 minus 0.1. So we already know that probability. So all we have to find is given, okay, we have to find, okay, perfect. So what we're trying to find, we're finding the probability of a delay given no technical problems. So we have to find the probability of delay and technical problems. So we're just going to list out all the different ways we can have a delay with no technical problems and no technical problems over the probability of no technical problems. Okay, no technical problems we established is 0.9 because technical problems is 0.1, 1 minus 0.1 is 0.9. So to find the probability of delay and technical problems, all we have to, or no technical problems, sorry, we have to just simply write out all the ways we can get a delay, making sure T dash is included. Okay, so we can either have T dash W dash C, because remember we only need one for a delay. So we can have not T, not W, C. We can have not T, W, and not C. So only needing one. Or we could have both weather problems and congestion problems. So we have T dash, W, and C. These are the three ways we could do it. So all we have to do, guys, is find the probabilities for each one. So we have 0.9 times 0.995. That's 1 minus 0.05 multiplied by 0.2 because we do have congestion. Okay, that's 0.171. T dash, W, C dash, 0.9 times 0.05 times 1 minus 0.2 is 0.8. That gives us 0.036. Remember, guys, we're multiplying these all together because they're independent. Okay, so the probability of each of them happening, probability of A intersection B, is probability of A times B because they're independent. Just wanted to make sure that was clear. Then we have not T, we have weather problems and congestion problems. So 0.9 times 0.05, that's the probability of W, times 0.2 probability of C, gets you 0.009. Now we add them all together to get that probability of delay and no technical problems is 0.216. So we're going to have 0.216 over the probability of delay, which we already, over the probability of no technical problems, which was 0.9, which gives us 0.24. Quite a nice answer in the end. Guys, give me a thumbs up if that all makes sense. Give me a thumbs up if that all makes sense. Smash subscribe if you love statistics as well. Smash subscribe. I'm going to leave the next question up just for a minute. Hope everything is making sense, guys. I hope everything is making sense. Let me know if not. Let me know if you have any questions about that. I wouldn't say that was too tricky of a tree diagram problem. Pax, do you want me to go over anything? Okay, I see some thumbs up. Okay, okay, okay. No, the hard question is some like 2023 stuff, okay? It's definitely horrible stuff. This is quite a nice question. I mean, could be a nice question. If you know how to approach this kind of question, it should be easy. I'm gonna start it in 20 seconds, guys. 20 seconds. Have a sip of water. It's a very nice day today. It's a shame there's an exam tomorrow. All right, cool. All right, let's go. The probability that this is a bit of like a binomial style question. The probability that a student answers correctly the first question in the exam or the multiple choice exam is 0.2. Fixed probability, we think a binomial. A random sample of 30 students which sat this exam is considered. So we have 30 students, n equals 30. Determine the probability that more than 5, but at most 10, so more than 5, but at most 10, so we're including 10, we're not including 5, students answer the first question correctly. Okay? We're going to have to use some binomial CD here. So we can define x to be the number of students who did answer the first question correct. The probability that they did, once again, guys, what did it tell us? The probability that they did get it correct was 0.2. So we're doing 30 trials for every student, and the probability that each one gets it correct is 0.2. We have a probability, we have our n. We want the probability that x is larger than 5, greater than 5, but it did include 10, so less than or equal to 10. This is the same as saying the probability that x is larger than or equal to 6 and less than or equal to 10. So we include 6, 7, 8, 9, and 10. Okay? It's discrete, so it's going to be a set number of students. You can't have 0.5 of a student, discrete, binomial. Okay? So to find this, all we have to do is the probability that x is less than or equal to 10, take away the probability that x is less than or equal to 5, right? Because we only want 10, 9, 8, 7, 6, so we want to get rid of 5, 4, 3, 2, 1, and 0, okay? So this is binomial CD for each of these probabilities. One of them is plugging in 10, one of them is plugging in 5 as your different x values. Your n will be 30, your probability will be 0.2. This gives us 0.974. Take away, there will be more decimals. I recommend to use these decimals in your, well, definitely use the decimals in your answer. Take away 0.4275. This gives you your final answer to be 0.5469. Nothing scary for this question, okay? However, part B is not ideal, okay? We're told that students earn 5 marks for answering the first question correctly, but lose 2 marks for answering incorrectly. Find the probability that the total number of marks scored by all 30 students in answering the first question is more than 17. Right, guys, so what are we thinking? What are we thinking? So how many students are going to earn 5 marks? The students who earn 5 marks are the number of students who get the first question correctly. But we've defined that as x, right? So it's going to be x times 5 to be the ones who get 5 marks. How many are going to lose 2 marks? It's going to be all the ones who get it incorrect. So we know there's 30 students in total. X will get it. If we want the ones who got it incorrect, it's just going to be 30 take away x, right? So what are we asking? The total number of marks is going to be 5 times x, take away 2 times, or minus 2, so take away 2, of 30 minus x, right? Those who got it incorrect, okay? So here's what we're going to do, guys. So what are we asking? The total is more than 17 of that first question, right? So 5 marks if it's correct, minus 2 if it's wrong. X students get it correct, 30 minus x get it wrong. The total marks that we get from that first question is t. So our total marks is 5 times x, the number who got it correct. Take away, because it's going to be minus 2 marks, 30 minus x times 2. Expand out these brackets, our total will be 5 minus 60 plus 2x. 5x plus 2x is 7x. We have 7x, take away 60 to be the total number of marks. So we want the probability that t is larger than 17, but we know that t equals 7x minus 60, right? From the equation that we made when considering our total number of marks. So because t equals 7x minus 60, we plug it into t here. So we have the probability that 7x minus 60 is larger than 17. All we have to do here, add over 60, divide by 7. So we have 77 over 7. That's just 11. So we're asking the probability that x is larger than 11. So that's what we're trying to find. Probability x is larger than 11. That's the same as saying the probability that x is larger than or equal to 12. You don't have to do this bit, guys. You can just know this is 1 minus the probability that x is less than or equal to 11. Plug this in your calculator. Number of trials was 30. Probability was 0.2, I believe. Yep. Binomial CD, so you plug in the 11, plug in your 0.2 and your 30. That will give you 0.9905. You do 1 minus this probability, as we established, to get 0.00949. That's your final answer. Let me know if you guys had any questions about this. It's all about defining the total number of marks. Thumbs up if you want me to move on. Thumbs up if you want me to move on. Boys, smash subscribe if you love statistics. Smash subscribe. I'm trying to get to 300. I have no idea what I'm on, but I hope I can get 300. That would make me very grateful. Very grateful, sorry. I hope the videos are helping. I hope the live streams are helping as well. I'm waiting for thumbs up and then I'll carry on. I believe we have an unknown mean, unknown standard deviation. We did do a question like that yesterday. I want to reinforce it. Can I explain the jumps in the last third lines? Yes, okay. So we know our total number of marks is 5 times. Oh, wait, just from here. Okay, we know the total number of marks is 5 times those who got the question correct. Okay? We also know those who got it wrong will be minus 2, because it's minus 2 for every get it wrong. 30 minus x, because those are the ones who got it wrong. X get it right, 30 minus x get it wrong. So our total is 7x minus 60 just by expanding this and doing 5x plus 2x. So we have the probability that the total, once again, guys, what we're trying to find, we're trying to check the probability that total is more than 17. But we know that the total is equal to 7x minus 60. So we can plug that in instead of t. But we know the distribution for x. This is good because we can put something in that we know the distribution of, okay? So we have the probability that 7x minus 60 is greater than 17. But instead of having t, you put in 7x minus 60. From here, we can do rearranging within our probability. Add over 60. Divide by 7. So it's going to be 77 over 7. So this is the probability that x is larger than 11. Probability that x is larger than 11. Here we're just using our binomial CD. This is the same as writing to be larger than 11. It's the same as being larger than or equal to 12. You don't have to do it like this. You could just say that the probability that x is larger than 11 is 1 minus the probability that x is less than or equal to 11. From here, we can use our binomial CD using probability 0.2 and number of trials m 30. And obviously our x value will be 11 here. Find this probability. 1, take away that probability for it to be larger than 11. And this will be 0.0049. I hope that makes sense. I hope that makes sense. That makes so much more sense. I didn't realize it. Yeah, it was just really, yeah, sorry. Guys, I would really want to use GoodNotes or OneNote, but I don't have like an Apple Pen or anything that I can share on my screen. So I hope this is okay. Oh, Fred's back. Fred's back. Fred, I did a little rigid body explanation. I'm gonna do it again later though, with all the like friction and I'm pretty sure you must have got it by now, because I know you're locked in, mate. You're gonna get an A star. But yeah, this question's pretty tough. It's tough. Once you know how to define the total number of marks, then it's okay. But it's all about getting that t in terms of x, because we have no idea what t is. Alright, I'm gonna put on the next question, guys. Next question. Unknown mean, unknown standard deviation. If you know how to do it, you know how to do it. Gonna leave it on for 30 seconds. If you guys have any questions about the last one, I can go back to it. I'm gonna leave it on for 20 seconds, guys. 20 seconds, then we're gonna get going. Got quite a few questions today, but to be fair, I hope they're helpful. A lot of these would be those like trickier questions, I would hope, that not a lot of people would get because we do know a lot of the yeah Pax is on it already. Can you explain how I got the total? How I got the total? Yeah, I'll do that quickly. The total number of marks, guys. Okay, let's remember what the question is telling us. You get 5 marks if you get it correct. Okay, and you lose 2 marks if you get it wrong. How many students get it correct? We had in part A that X students. Remember we defined X to be the number of students who got it correct, right? So X times 5 will be those total number of marks for those who got it correct. For those who got it wrong, if you didn't get it correct, you got it wrong. So out of our 30 students total, you take away your X from that 30. So 30 minus X students got it incorrect. X correct, the rest not correct. And we know when you get it incorrect, you lose 2 marks. So our total marks will be 5 times X, those who got it correct. And then we have minus 2 times 30 minus X. Because these are all the ones who got it incorrect. From here, you just expand and then you plug it in because we're trying to find the probability that the total is larger than 17. I hope that makes sense. Fred, I hope that makes sense. That's how you get the total marks, okay? Okay, so let's go through this question, guys. I hope that's good, Fred. I hope that's good. But let's go. The weights of baking apples are thought to be normally distributed. 2.5% of these apples are heavier than 250 grams, and 1% are lighter than 144 grams. Find the mean and standard deviation of the weights of baking apples according to this model, and then give your answers correct to the nearest integer. Okay. So if in doubt, draw it out, guys. If in doubt, draw it out. Okay. So W, we're going to call W the weight of our baking apples. We're going to say it's normally distributed with mean mu and variance sigma squared because we don't know it. Draw out the information that they tell us, guys. If you want to draw your normal bell curve, 1%, so 0.01 of our area is less than 144, and then 2.5%, so 0.025 will be more than 250, okay? And then this axis is going to be the W axis, right? Because these are realizations or like the values, sorry, that our random variable W can take, okay? Don't stress too much. So what do we want to do? Let me just make sure I didn't do anything bad, okay? So what do we want to do? We're going to use the standard normal. Our standard normal Z is equal to our X value minus the mean over the standard deviation. And our standard normal has mean 0 and standard deviation 1. So what we want to find is the corresponding Z values, which have 0.01 area to the left and 0.025 to the right. Okay? So we're going to use our inverse normal. Okay, Fred seems like he's happy. So we're going to use our inverse normal to find the corresponding. Is my chat that delayed? Jesus. To find the corresponding Z values. Okay? So our area to the left is 0.01. Inverse normal have the mean 0, standard deviation slash variance 1, because 1 squared is 1. This will be giving you, minus 2.326347931. Okay? Write out the decimal places or store your answer in your calculator, either way. Then remember, inverse normal, it gives the area to the left. So we don't plug in 0.025, we plug in 1 minus 0.025, mean 0, standard deviation 1. Okay? This gives us 1.95996408 as our other Z value, right? So this minus 2.32 will correspond to the 144, and this 1.9599 will correspond to the 250, okay? So we know how to standardize. So exactly that, guys. The minus 2.326 will be equal to our 144, take away mu over standard deviation. Okay, I'm happy that made sense, Fred. And then our 1.95 will be equal to... No, Fred, I'm going to do the explanation on the hinges at the end when we do mechanics, okay? Our Pax is on it, I've got to speed up. We have our 1.95 to be equal to 250 minus mu over the standard deviation. You could write it out like this, guys. I wrote it in red because you can just ignore it. Set up the simultaneous equations, multiply each side over by our standard deviation, okay? So we have, where is it? This minus 2.326. Once again, write it out or store it in your calculator. Times by sigma equals 144 minus mu. Then a second one is 1.9599 times sigma equal to 250 minus mu. Simultaneous equations, solve them how you want to. The way I'm going to do it is equation 2, take away equation 1. So we have minus mu, minus mu, the mu's cancel out. Then we have 1.9599 minus 2.326, so that's plus 2.326. Remember all those decimal places, this gives you this 4.286311,959 sigma. This will be equal to 250 minus 144 is 106. So then divide over by this 4.286, gets you 106 over this 4.28 number. That will be our standard deviation. This gives us 24.73, nearest integer. They wanted it in the nearest integer. This would be 25. We round up, 24.73 goes to 25. Now to find the mean, all we have to do is plug in the standard deviation into either one of our equations to find the mean. Whichever one you want, take your pick. So we're not going to use 25, guys. We want to use our unrounded answer to get the most accurate value for mu. So we do, for example, we can do 250, take away 1.9599 and the rest. Sigma to be equal to mu. So we'd add over mu, we take away this 1.9599. So we get a mu equals 250 minus all of this times by our value for sigma, which is 24.7298. And this would give us mu to be 201.5929, nearest integer 202, exactly what Pax said. Perfect, Pax. Hope that makes sense. Do you recommend using the simultaneous equation button on the calc, or is method mark solving them working? Ooh, that's a good question. I haven't been looking at the mark scheme too often recently. I'll definitely recommend writing something down about solving simultaneous equations. Definitely set them up. And maybe just kind of like almost lie in a way, just say there's no harm in writing out working. There's never any harm writing out working. If it can take you less than 20 seconds, you might as well do it. Okay? You can solve it in your calculator, check it in your calculator for sure. Definitely do that. But from there, I wouldn't stress too much about wasting too much time about adding and subtracting. But you might want to check that on a past paper question because the mark schemes I'm doing are international, and I don't want to give you guys past paper questions you've seen. So sigma is the standard deviation. Sigma is the standard deviation. Do they want the variance? Oh, they want the standard deviation. Okay. The sigma is standard deviation, guys. Sigma squared is the variance. Yeah, yeah. Okay. Moving on to part B. You may use the mean and standard deviation you found in part A. You may use, okay? Nice to know. The mean and standard deviation found in part A to be given, okay, our conditional probability, they're telling us the word given straight away. A baking apple weighs more than 227, so given is more than 227. Smash subscribe if you're 227 grams. Determine the probability, it weighs more than 250 grams, okay? So given 227, what's the probability it weighs more than 250? So we're trying to find the probability of more than 250 given more than 227, okay? Let's write out our conditional probability formula. Remember, guys, we may use. Okay, this is quite key to this question. It's a bit sneaky of them, yeah? Because I feel like in the brain off adrenaline of the exam, it's a little bit. You might just apply it very quickly. So we want the probability that our weight is more than 250, given is more than 227. We know the probability of A given B is the probability of A and B over the probability of B. So our new to be the probability that W is larger than 250 and larger than 227. Or to be larger than 250 and 227, you must just be larger than 250. So we over the probability that W is larger than 227. Here's the thing, guys. We know the probability that W is larger than 250. In the adrenaline of the exam, you might think just to plug in mu is 202 and our standard deviation of 25 into your calculator. Okay? You may think to do that for each one, but remember what they told us in the question. I wrote it down on the diagram. We already know that probability that W is larger than 250 is 2.5% or 0.025. Okay, so we have to use that. In general, in A level, they won't be this sneaky, but it's good to point it out. You never know what they're going to throw at you. So we have 0.025. Probability W is larger than 227. We have our mean to be 202. We have our standard deviation to be 25. Our lower is 227. Our upper is some really big number. Okay? Yeah, sigma is standard. Guys, is the chat this delayed for me? I don't know if the chat is this delayed. Whereas right now, someone say something. I'm going to see how long it takes. Okay. So, where were we? Upper, yeah. So probability W is larger than 227. Plug it in the calc. Normal CD. 0.15866, and then the rest of the decimal places, do your 0.025 divided by 0.15866 will give you 0.158. That's it. Okay, I replied. I replied now. I've just seen that now. Yeah, sigma is your standard deviation, sigma squared is your variance, because we know we have to square root our variance to get our standard deviation. Sigma is standard deviation. Trust me, I just did a stats and probability module, guys, in uni. I got all my results today. I'm confident enough to say that sigma is the standard deviation. So yeah. We're gonna put on the next question, guys. Let me know if you have any questions on that one. You were on question lol. What? Okay. Bit of normal hypothesis, guys. And then we have a horrible discrete one after this. Try focus, chat for a minute. I'll tell you exactly in seconds. Okay, I'll reply to this. How did I do? I did well, guys. I got a 95 actually. I was very happy with that. I put a lot of effort into my stats just because I'm doing a lot of stats modules and potentially my masters in stats as well. Sorry, guys. Look into this though. It's not about me. Look into the content. Okay. Okay. Gonna wait 20 seconds before we start. Kind of see what SB is saying about my response times. All right, boys. Let's go through 25 seconds. Okay. Okay. Fine. What does 95 mean? I got 95 out of 100 in the module. Sorry, I'm not trying to lie. Not trying to. Guys, it's not about me. Let's go into this. The times in minutes taken by Year 6 students to complete the SATs science test are assumed to be normally distributed with a mean of 48 and a standard deviation of 5. Okay? This is great. They tell us the mean and the standard deviation. Really friendly question. Okay? Let's continue on. Just tracking the time, make sure everything's good. Alright, cool. So yeah, normally distributed with a mean of 48, standard deviation of 5 for their time to take the SATs science test. 8% of students finish the exam in less than t minutes. Find the value of t correct to the nearest minute. Okay, let's go. So draw it out, guys. If in doubt, draw it out. You could do it in your head, but why not? So we're going to call t the time to complete the exam. They tell us it's normally distributed with a mean of 48 and that variance, or so standard deviation 5, variance is the standard deviation squared, which is 5 squared. Okay, draw it out. We have t, this unknown time here. We're told that 8% are less than that. So we want the probability that t is less than t to be 0.08. This is inverse normal, guys. Sorry, inverse normal. Plug in 0.08. Okay, yeah. Plug in your mean, plug in your standard deviation to be 5. This gives you 40.975. Nearest minute will be 41 because they wanted it to the nearest minute, okay? We have to determine the probability that a randomly chosen student took more than 57 minutes to complete the test, okay? Also, nothing too bad. We want the probability that t is larger than 57. Now we already have the mean and the standard deviation. Just some normal CD, guys. Your lower is 57. Your upper is a really big number. We have the mean to 48. We have standard deviation is 5. Okay? And this gives you 0.0359. Okay? Just plug in your calculator. Nothing scary there. Let's carry on. So 20 students that sat the SAT's science test are selected at random. Okay, 20 students. Calculate correct to 3SF the probability that more than 2 of these 20 students took more than 57 minutes, to complete the test. So what are we thinking, guys? What we think? What distribution is this? What distribution is this, guys? We've been working in normal. We've been working in normal. But in this case, what are we thinking? They want the number of students. Yeah, these marks are not right. These marks are not Edexcel marks, okay? Okay, so 20 students, a fixed number of trials, right? Because we know the normal, right? So 20 students that sat the SAT science test are selected at random. Calculate correct of 3SF the probability that more than 2 of these 20 students took more than 57 minutes to complete the test. We have 2 outcomes. Exactly, binomial, and then use the probability from the previous part, because we have 2 options. Either they took more than 57 or they didn't take more than 57. Fixed probability, the probability that they took more than 57, number of trials are 20. Perfect, perfect, perfect. So we're going to call X the number of students who took more than 57 minutes. Once again, we have a success or a failure. They either did or they didn't take more than 57 minutes. They either take, yeah, exactly that, take more than 57 or not. The fixed probability that we have from part A, I believe, or part AII, or part B, sorry, is 0.0359. It is right here. That's the probability t is larger than 57. We have independent trials, a fixed number of trials, and a fixed probability. The number of trials was 20, they told us. We want the probability that X is larger than 2. Larger than 2. I'm not sure what's going on with this bracket here. It should say probability that x is larger than or equal to 3. Oscar's already on it. So 1 minus the probability that x is less than or equal to 2. Okay? Because once again, they want us that it was more than 2. So we're going to do 1 minus the probability that it was less than or equal to 2. Okay? And then plug it into your binomial CD for that probability x is less than or equal to 2. Number of trials 20, probability 0.0359. This will give you 0.966. One, take away this will give you 0.0334 to 3 significant figures. In this case, they did specify. You guys saw the next part I was going to ask you, but this is specified to be 3 significant figures. Let's carry on, guys. Let's carry on. Part D, Part D, Part D. It is claimed that top set students take less time to complete the exam as the mean finishing time of a random sample of 6 top set students was 44 minutes. So we have a sample. You guys already saw that it's going to be, yeah, Pax, you saw already it's going to be one-tailed. Test this claim at the 1% significance level. So what are we trying to see? So we're saying that the top set students take less time. We're trying to see that this value is such a smaller time, such an extremely lower time, how do you say less time, that we're thinking that our original mean would not be appropriate. We're saying this is such an extreme value that will disprove the original distribution. That's what we're asking in a hypothesis test. This is one-tailed because we only care about the less time. We don't care about a change in time, it's less. Remember, when it's greater or less, that will be one-tailed. Okay. Right, so let's go through it, guys. The null hypothesis is just what we originally had. The null hypothesis is going to be that our mean is 48. Alternative, we think these top set students are very smart and quick, is that the mean will be less than 48, where mu is the mean. So we have our sample mean, they tell us to be 44. Remember, guys, what changes in our sample mean distribution? The mean stays the same, but we divide the variance by the number in our sample size, right? Sample size is 6, so we have sigma squared over n. For the standard deviation, this would just be sigma over root n, but okay. So we already know. So this is what we're checking. We're checking if this value is so extremely negative, or so negatively extreme, not sure why I wrote it like that, the probability of seeing it is less than 1% given our original distribution. Yeah, Oscar's on it. So we have to check the probability that our sample mean is less than 44. Sample mean because we take, once again, guys, it's 5 over root 6. Why is it 5 over root 6? Because we know our standard deviation is 5. They tell us in the question, okay? We have to divide it, the standard deviation, by root of the sample size, or the variance divided by n. It's the same thing. One is just taking the square root of the other. Standard deviation is the square root of the variance. So exactly that, guys. We have a standard deviation to be 5 over root 6. Our mean is 48. So we're going to check the probability that our x bar, or our sample mean, is less than 44. You plug in 44 for the upper. Lower is a really negative number. This will give you a probability of 0.025, which is larger than 0.01. The p is not low, so we don't reject the ho. Okay? Insufficient evidence to reject h0 at 1%. So you can say there's no evidence that top set students take less time. Because the probability, you could use a critical region, guys. If you wanted to use a critical region, what you would do is you go to your inverse normal. You put in, it's a 1% significance level, so you can put in 0.01 as your area. Your standard deviation is still 5 divided by root 6. Your mean is 48 because we're taking the original distribution. That would give you a value of 43.25. So anything less than or equal to 43.25 will be in our critical region. 44 is still within not within our critical region. It's larger than 43.25. I'll put it up here. Larger than 43.25. H1 is less than 48. Sorry, 48. Yeah, because we're thinking about what we had originally, not the new one. But yeah, I hope that makes sense, guys. Let me know if you have any questions about this normal hypothesis test. I think that's all good. Okay, guys, we have a disgusting question. We have a horrible question. This is an A-star question. If this comes up, I would say a lot of the things in this question are A-level maths exam things that we have seen in past papers or in predicted questions. I know predicted questions are a bit dodgy, but I would say they're not completely dodgy. If something hasn't come up that isn't the specification, then you have a feeling that it's more likely to come up. Okay, Pax is happy. Pax is happy. I'm happy, bro. Pax, I know Pax is getting the A stars, but I hope he gets it anyway. I hope he gets it anyway. How many questions left? We got quite a few questions to be fair. Quite a few questions. We got a normal hypothesis. Sorry, we got this. Actually, not too many. Discrete random variable. We're gonna do a forces and friction question, and then I have two static rigid bodies, but the main point of them is to try and understand how all the forces change depending on what they give you. I'm basically gonna cover every single thing we have looked at, not the full question, just the diagrams to try and understand how things change in terms of reaction forces for static rigid bodies, not with particles. We have one particle question, but everything else will be static rigid bodies. We're gonna go through this question in 20 seconds, guys. 20 seconds. So yeah, we got this one, three more, I believe. We're doing quite a few today, guys. It's last stream, last maths exam. For those of you who don't, well, for those of you who don't have chemistry, last exam, which is pretty big, pretty big. Focus up though. Remember, guys, you're not done yet. You're not done yet. Smash subscribe if this is helpful, guys. This question is not Mr. Jordan approved. Do you know what's crazy? I had Mr. Jordan every single year while I was at school. Every single year. All of secondary and all of sixth form, I had Mr. Jordan. So, yeah, yeah. Mr. Jordan's a really good maths teacher, though. I'll say that. Very good maths teacher. Better than Neil does maths. Better than Neil does maths. All right, let's go, guys. Let's go. The probability distribution of a discrete or random variable x is given by the probability that x equals x is k for x equals 1. So this is like those geometric or sum to infinity questions that we saw before, those geometric series questions. Similar idea. So the probability that x equals 1 is k. Then the probability for x equals 2, 3, and 4 is half times the probability that x equals x minus 1. So the probability of the next number will be half times the probability of the previous for 2, 3, and 4. Okay? Where k is a positive constant. So guys, before in this question, I'm going to say find k first. I reckon if they give you a question like this, they'll tell you find k. So I'm going to tell you to find k first, and then we can work from there. So where were we? K is a positive constant. Great. Three independent observations of x are made. Okay. Denoted by x1, x2, and x3, and the variable y is defined by, or defined as y equals our three observations added together. x1 plus x2 plus x3 is similar at the start, and then it gets a lot harder. If y is an even number, determine the probability that y is greater than 9. This is a good question, guys. Good question. A lot of key skills. So where do we start? Find k. Let's find k first. Ignore all this y stuff. Ignore the y stuff. Let's find k. Okay? So when we see this discrete distribution, we're going to draw out our probability distribution table. Okay? So let's visualize this. They may give it to you in a bit of a nicer form if they give the question like this in the exam. So ignore y for now. It's a discrete random variable. Draw out your distribution table. So what do we know? X can take values of 1, 2, 3, and 4. Otherwise, the probability will be 0. So we only care about x equals 1, 2, 3, and 4. The probability of each of these. So we know the probability of x equals 1 is k. They tell us in the question. Then each time we times the previous probability by a half. Okay? So probability x equals 2 will be half times the probability that x equals 1. Okay? X minus 1. So plug in 2. 2 equals x minus 1. So each time we're multiplying by half. So the probability x equals 1 is k times by half, 2 is half k times by half, for 3 will be a quarter k, and for 4 will be an eighth k. Each time we times by half. It's not a sum to infinity this time. Not a sum to infinity this time. There's no dot dot dot. It's just for these given values. But we do know that all of these probabilities must add up to 1, because the sum of all of our probabilities must be 1. Exactly, Pax. So to find k, we can just do k plus a half k. Yeah, everyone's got that. Plus a quarter k plus an eighth k will be equal to 1. Okay? So all you do, you can factor out k. So we have k times by 1 plus a half plus a quarter plus an eighth equals 1. Add these up in your calc or in your head if you really want to. Don't do it in your head in the exam. We have 15 over 8 times k equals 1 times over by 8 divided over by 15. So we have found that k equals 8 over 50. From here, so we found one part. This would be already a decent amount of marks. And there's a good chance that if they ask you a question like this, you will have to use this information about adding to 1 when you see these discrete random variables. Okay? But let's move on, guys. You never know, they could ask something hard like this. And this kind of question could come up, okay? You never know. Yeah, remember to switch from radians to degrees as well, guys. That's a good point. So what do we have? Three independent observations of x are made. x1, x2, and x3. The variable y is defined as x1, x2, x3. So each time we're generating a value of x, because remember, we have these probabilities that we will now be able to fill in because we know what k is. So we generate a certain value of x. We know the probabilities that we can get each value, okay? And this will be equal to y if we generate 3 values of x and add them up. If y is an even number, determine the probability that y is greater than 9. So if y is even, what is the probability that is greater than 9? So we want the probability that y is greater than 9 given y is an even number. If they ask a question like this, you will already get marks. If it's not a sum to infinity, why do they say 0 otherwise? Because every other number, any other number probability would be equal to 0. If I put 5, 6, 7, 8, whatever it is, that probability will be 0. So the probabilities for x being 1, 2, 3, and 4, those are the only values our x can take because it tells us in the question. 0 otherwise means if I what's the probability x equals 5? 0. It's not part of that recurrence relation. It's not a viable value for x. X can only take that value. It's like rolling a dice. The probability of you getting a 7 is 0. Okay? Just an analogy, yeah? So spotting this is a conditional probability if y is an even number. So we want the probability that y is greater than 9 given y is even. Okay? The first place I would start, guys, we now know k. Fill in your table with k. We saw this in 2023. Rewrite your table with your probabilities now that you know the unknown. Okay? So just plugging in k equals 8 over 15 into our k, half k, quarter k, and eighth k. Just plug it in. This gives you what 8 over 15 because this was just k. And half k, 4 over 15. A quarter k is 2 over 15, and an eighth k is 1 over 15. Okay? That's just plugging in a probability table. Now you get marks for every step you show, guys. The probability that y is larger than 9 given y is even. Always write out your conditional probability formula. If they give you a conditional probability, they're going to want you to write it out, right? It will probably help you in the question somehow, like we saw in 2023. Okay? I'm just preparing you guys in case we see a hard question like this. So write it out. We know in the numerator, probability of A given B is the probability of A and B over the probability of B. So this is the probability that y is larger than 9 and y is even. In this kind of question, guys, it helps to write things out. I'll say that now. Over the probability that y equals even. So first thing we're going to do, let's find the probability for x's to be even and odd. Because we know that y is adding up our x values, right? So how, they always ask conditional probability implicit. Yeah, exactly. So first of all, let's just find the probability that x is even or odd. Because we know we're adding 3 numbers and we're going to determine whether y is even or odd. Because we want the probability that y is even. So we're thinking, how do we add 3 numbers to make an even number? What numbers do those have to be? So the only thing that we care about is whether x is even or odd. We'll walk through this step by step. So the probability that x is even, so our even numbers will be 2 and 4. Add those together, that's 4 over 15 plus 1 over 15. So the probability that is even, an even x is shown, is a third. Probability that is odd, we add probability that is 1 to the probability that we get 3. It's 8 over 15 plus 2 over 15. So this is just determining whether we get an even or an odd x value, because that's all we care about. Because remember, for y to be even, we have to add either, let me know guys, what do we have to add? If we have 3 numbers, what would we have to add together in terms of even and odd to make an even number? If we add 3 numbers together and we want an even number to be the result, what do we have to add together? Okay, I know it takes 20 seconds, so I hope that will match up. So the probability that is odd will be probability that's 1 plus the probability that it's 3. 10 over 15 is 2/3. Okay, just add these together. I'm going to wait 10 seconds in case anyone writes down the answer. Actually, I'll see it anyway, so people would have wrote it down. Okay. So how can y be even? Y can be even by either adding 3 even numbers. If you add on 3 even numbers to each other, you get an even number. The other way, odd or even, exactly. Yeah, perfect. Robbie is on it. The other way you can get, is it Robbie? Yeah. The other way you can get even, as Robbie said, is 2 odds and an even. Perfect. Perfect. So, what we're going to do, the probability of getting 3 evens, guys, this is what we care about. We care about the probability that y is even. So the probability that y is even would be the probability that we get 3 even x's, first of all. So this would be a third times a third times a third. Perfect. Does that include the 0 value? X cannot take the value of 0. We've said it's only defined for 1, 2, 3, and 4. They do not tell us that x can be 0. X can only be 1, 2, 3, and 4. The 0 was the probability, not the value that x could take. Okay? So adding together three evens, to get three evens, we do a third times a third times a third to be 1 over 27. Now, there are three different ways we can get odds, two odds, and even. We can either have odd, odd, even, or sorry, odd, odd, even, or even, odd, odd. That even number can be in the first, second, or third positions, right? So there's three different ways to get two odds and an even. They can ask this kind of question. They could ask this in like a tree diagram question as well, guys. So it might not just be in a tricky question like this. It could also be in a simpler question, but still knowing about these even and odds. Okay. So how do we do this? So probability of two odds and an even, 2/3 times 2/3 times 1/3. Okay. And because there's three ways to do this, we multiply this by 3. It will give us 12 over 27. So the total probability that y is an even number, just going to put my phone charging quickly, will be 1 over 27 plus 12 over 27. Okay. Hope that makes sense. Hope that makes sense. Give me a thumbs up if you're staying with me so far. Okay. So then from here, we know the probability that y is even. Add them together, we get 13 over 27. Great. This is really good. So now what we have to check is how can we get y is larger than 9 with either two odds or one even. So two odds and one even or three evens. Because remember what we're checking, guys. We have the denominator now. This is good. You'd already get a lot of marks for finding this, guys. Yeah. Y is 4 over 15 plus 1 over 15 gives you an even number. Because we know the way we can get an even x value would be to either get 2 or to either get 4. Okay? To get 2, the probability is 4 over 15. To get 4, the probability is 1 over 15. So the total probability to get an even number, we just add the two probabilities together. Okay? Then the numerator. The probability that y is larger than 9 and y is even. Okay? Okay, so what we have to do here, just write it out, guys. Write out your three numbers with the condition that all three are even or two are odd and one is even, because that's given that y is even. We've established for y to be even, we have to have three even x's or two odds and one even. So simply just write out what you can. It won't be that many combinations in this kind of hard question. So using 1, 2, 3, and 4, write out what you can for y to be larger than 9, so our three x values to be larger than 9, and the condition that all three are even, or two are odd and one even. So what do we have, guys? So if we want all three to be even, there's actually two things we can do. First of all, 4 plus 4 plus 4. So we want y larger than 9, right? Or larger than or equal to 10. 4 plus 4 plus 4 is 12. That fits the condition. Perfect. So we can get three fours. To get three fours, we know the probability of getting 1 4 is 1 over 15, right? So to get three fours is 1 over 15 cubed, or 1 over 15 times 1 over 15 times 1 over 15. Okay, that's 1 over 3,375. That's the probability of getting three evens. Or sorry, three fours. Okay, if we want two odds and an even, the only way we can get two odds and an even is if we have 4 plus 3 plus 3. This equals 10. There is no other way to get two odds and an even to be larger than 9 or larger than or equal to 10. Because 4 plus 3 plus 3 is 10. So if we try and do using ones or using a 2 instead as our even, we're not going to get large enough. There is one more thing that we can do, Robbie. There is one more that we can do, which requires still three even numbers. Because remember, we don't care if they're the same number. Still three even numbers, okay? So to get 4, 3, and 3, would be 1 over 15, and then the probability for 3 is 2 over 15. So we have 1 over 15 times 2 over 15 times 2 over 15. However, same idea as before. To get 4 and 2 threes, there are three ways we can do this. We can either have that 4, 3, 3, 3, 4, 3, or 3, 3, 4. Remember, guys, it's not going to be the 3 factorial. It's not going to be every single combination because the two threes are the same. We don't care about the order of those two threes. We only care about the rest. 2, 4, 4 is the other one. Yes, 2, 4, 4 is the other one. So we times the probabilities together. We see there's three different ways we can do it. So we times it by 3. This gives us 4 times 3 is 12 over 3,375. Okay? Now the other way to get three evens, not all the same. So before we had all the same evens. So here we have, like you guys said, 4, 4, and 2 gives you 10. That's larger than 9. Probability of getting a 4, and a 2 be a fifth. Sorry, 1 over 15 times 1 over 15 times 4 over 15. Once again, three different ways to rearrange this, guys. Like with our 4 and 2 threes, with our 2 4s and a 2, we can either get 4, 4, 2, 4, 4, 2, classic, 4, 2, 4, or 2, 4, 4. Okay? So we just do it 1 over 15, so our probability for 4, times 1 over 15 times 4 over 15 for the probability of 2, 3 ways multiplied by 3. So we have 4 times 3 is 12 over 3375. Now we add these all together because these are all ways that we get y larger than 9 given y is even. Okay? So 1 plus 12 plus 12 is going to be 25 over 3375, right? So you add these all together for that numerator. And we already found the probability that y is even. So we have 1 plus 12 over this is 1 over 135. So this is 25 over 3375. Put in your calc, gives you, just using slang, 1 over 135. So now we have our numerator. From before, we had our denominator to be 13 over 27 to get y equals even, or sorry, to get an even y. Put in the calc, gives you 1 over 60, 1 over 65. Pax logged out. This question, they would guide you. They would ask you to find k. They would most likely ask you to find probability of y is even, and then they would give you the conditional. Yeah, if they gave you a question like this. I would not say they would give it just blankly like this, and I would say each of these skills are quite relevant. The even and odds, they like that stuff, whether it be a tree diagram question or a distribution question. They do like that kind of stuff. With what else do they like to do in this? Conditional probability, very relevant. Finding your unknown constant in discretes, also relevant, whether it's the sum to infinity or it's the in this case not a sum to infinity, just adding a few terms. I hope that's all good. I hope that's all good. Alright guys, we have finished the statistics section. We're gonna go on to 2 or 3 mechanics and I'm gonna explain the rigid bodies forces, essentially. Could you scroll up so I can take a pic of the question? Yep. I can make this available after. I'll put it on my link tree in my bio. Oh yeah, you can rewind that. You guys can rewatch the live, of course. Yeah, subscribe if you like YouTube. Trying to hit 300 subscribers, guys, by the end of the exam season. Trying to help you guys out with these live streams. I hope they are helpful. But I see people returning, so I do hope these are helpful. We have no idea what's going to come up tomorrow. Remember, guys, I'm focusing on tricky questions. There are many topics that I'm not doing that are going to come up. Yeah, like certain formulas, like finding your standard deviation. For example, these speed, time, velocity graphs, all those ones, SVA. It's all a bit easier. I'm not covering them because I want to do some hard stuff. Okay, guys, I'm gonna put on the next. Okay, so guys, switch your mind. You're gonna have to do it in your exam. Switch your mind now. We're going mechanics. Okay. I'll give you guys 20 seconds to read the question. Cheers for had 9 live. Had 9 subs a week ago. Yeah, I'm just trying to do as much as I can now, I guess. Make Connor and Jordan use these lives as homework for next year's year 13s. I hope so. I hope so. I would love to see Connor and Jordan again, to be fair. They got me those A stars. Alright guys, let's go on to some mechanics. A little bit of mechanics as Neil does maths, it says. So let's go. Forces and friction, guys, forces and friction. Give me a thumbs up if we're happy about forces and friction. Right, let's go. It's a tough question, guys. A box of mass. Oh yeah, I remember. I want to do this on a OneNote just to make my. Oh my god, what's going on here? I just lagged a lot. Looks like we're all good though. It's just loading up. Okay, here we go. All right, here we go. So a box of mass 60 kilograms is held in limiting equilibrium. Guys, limiting, slipping, tilting, or accelerating. What is that telling us? What is that telling us? A box of max 60 kilograms is held in limiting equilibrium on a fixed rough inclined plane. Rough plane, guys, rough plane. So we have limiting equilibrium and a rough plane. Obviously, that makes sense that it's going to be happening, but yeah. We box of mass 60 kilogram held in limiting equilibrium on a fixed rough inclined plane held by a rope. The plane is at an angle of 20 degrees to the horizontal, as shown in the figure above. Yep, friction max, perfect. Yep. F equals mu times R. Okay, cool. The rope lies on a vertical plane containing a line of greater slope of the inclined plane and is inclined to the plane at an angle of 35 degrees. Just look at the diagram, guys. They love to waffle and confuse you. The rope is modeled as a light, inextensible string, so we have that constant tension. The acceleration part is not relevant here. Guys, say in the chat, is it light or is it inextensible about equal tension? Which part is implying equal tension? They may ask that. They may ask that as a one marker. And the box is modeled as a particle. Okay, good. The coefficient of friction between the box and the plane is a quarter. So we have mu equals a quarter. Yes, F max is for moving, or if we're in limiting, slipping, or tilting. Okay, or moving. Moving is also included because that friction has to be at its maximum if you're pulling something, right? You have the maximum force going against it before you start moving. Then when you start moving, that frictional force is still there. Okay. I'm seeing some people say light, some people say inextensible. Let me carry on for now. All right, guys. So first things first. Let's label out our diagram. I'm gonna be using my pre-drawn diagram, obviously, because I don't have OneNote, but I'm gonna be labeling what we see. Okay. Actually, you know what? I hope you guys didn't see that. We have to determine the least possible tension in the rope, guys. The least possible tension in the rope. The key thing is the least. So if we're trying to determine the least possible tension in the rope, which way will friction be going? I hope I didn't show it. I may have shown it. Will friction be going this way, up the plane, or will it be going down the plane? So in limiting equilibrium, we want the least possible tension in our rope. So this will not be moving. It will not be moving. And we want the least possible tension. I know it takes 20 seconds, so I'm kind of repeating myself here. But yeah. So which way is tension going if we want the least tension in the rope? The least possible tension. We have our thing. It's being held still. Exactly. It's being held. Friction will be going up. Up the plane, up the plane. Perfect, perfect, perfect. It'll be up the plane, guys. Why? Because it's trying to move down. It's trying to move down right now. We want the least possible tension to be holding it up, right? If we want the least possible tension, that means friction, because it's on the edge of going down, friction will be preventing it from going down. Okay? I hope that makes sense. I hope that makes sense, guys. So there we are, labeling it, guys. Let's label our diagram. So what do we have? Mass of 60 kilograms. Okay, so we have our 60G going down from our box slash is modeled as a particle. And then as we know, so they tell us mu is a quarter, limiting equilibrium, our friction will be at its maximum, will be equal to mu times r. Okay, we have a rough plane, so there's going to be friction, as we already mentioned. The least possible tension, which way is friction going? It's going to be going up because that block is trying to go down. We want the minimum amount of force needed on that rope to prevent it from going down. Therefore, friction is going to have to be working at its maximum, okay, to prevent it from going down. So what we do, as we always do with these questions, we're going to resolve perpendicular to the plane and parallel to the plane. Whereas if it was a rigid body, we'd be just doing vertical horizontal, but when we have some particle, we have to go perpendicular and parallel to the plane, okay? So we have our reaction force, naturally. And we also have, so this 60G we split into a vertical and horizontal component, or sorry, a perpendicular and a parallel component. We're going to do force multiplied by cos 20, so our force is 60G. That's going to be multiplied by cos 20 because this is the adjacent side. The coefficient of friction is 1/4. Coefficient of friction is 1/4. Mu will be a quarter here. Our mu is a quarter. And then a parallel going downwards due to our weight of our box will be 60G sine 20 because this is the opposite side. And then looking at our tension in the string, because we know that this angle is 35, they tell us in the question that it's 35, splitting this up into a perpendicular and then parallel to the plane component. The perpendicular component going upwards will be t sine 35. Why is it t sine 35? Because our hypotenuse is t, our angle is 35. We want the opposite. We know opposite over hypotenuse is sine 35. Multiply through by the hypotenuse. I would recommend just knowing this in the exam. The opposite one is going to be sine, and the adjacent one is going to be cos. So opposite will be t sine 35, and the adjacent one will be t cos 35. Okay? So from here, as we know, once again, the friction is going up. We are about to slip down, guys. We are about to slip down. Okay, so going back to my notes. Just give me a second, guys. So what we're going to do, because we're in equilibrium, remember guys, the fact that we've already put friction going up the plane implies we don't need to worry about that least thing anymore. Now we can just solve it normally with our parallel components being equal and our perpendicular ones also being equal. And then we may have to do some substituting or arranging. So by resolving parallel and perpendicular to the plane, so let's quickly go back to OneNote actually. So what do we have? Going perpendicular, going upwards, we have r and t sine 35, and then going downwards, we have 60g cos 20. So r plus t sine 35 will be equal to 60g cos 20. Then quickly looking at our parallel to the plane, we would have going up the plane, our friction, t cos 35, and then going down the plane, we have 60, or down parallel to the plane, we have 60g sine 20. Okay, so we set those equal to each other, and then once again, we are trying to find, if it lets me switch back, we are trying to find the T tension in the rope. Okay, so set up your equations and then work from there. So setting up our equations, we have 60g cos 20 equals R plus T sine 35, as we said. Then we have T cos 35 plus mu R, that's the maximum friction, equal to 60g sine 20. What we want to do is we know mu, guys. Mu is a quarter, remember? We're trying to find T. So if we can rearrange our first equation up here to find R, then substitute it into our second equation, we can then multiply for, then we can rearrange, for T, because we know every other value. Okay, so let's find out what R is. R will just be 60g cos 20, take away T sine 35. Okay, sub this into your second equation. So we have T cos 35 plus mu times, mu is a quarter, guys. We do know mu, just reminding you. I just wrote it out like this. You could already write in a quarter. So we have 60g cos 20 minus T sine 35. That will be equal to 60g sine 20. Okay, we want to find the tension on the rope, so we're going to make T the subject. So we can immediately expand all of this out. So we have T cos 35 plus mu 60g cos 20 minus mu T sine 35 equals to 60g sine 20. Okay, we want to get all those T's on one side. So what we're going to do is we're going to take away over this mu times 60g cos 20 just to have our T's on the left. So we have T cos 35 minus mu times T sine 35 equals, it should be an equals, 60g sine 20, take away what we had here, which is our mu 60g cos 20. From here, we factor out the t, then we're going to divide over by cos 35, take away mu sine 35. Remember, we know every single value here. We know every single value. So t will be 60g sine 20 minus mu 60g cos 20, where mu is a quarter, over cos 35, take away mu sine 35. Once again, mu is a quarter. Plug it in your calc with all the relevant values, mu being a quarter, once again. This gives you t equals 93.1887. Three significant figures. We are in mechanics. Whenever we're in mechanics, we want it to three significant figures. This is going to be 93.2 newtons. Thumbs up if we're happy, guys. Thumbs up if we're happy. 338. Thank you for paper 2 chemistry. Couldn't have gotten the 4 marker. Purification. Yeah, I'll be honest, I had a feeling it was going to come up, but I didn't want to say predicted. But I feel like with chem, they tend to test the specification quite well. So I just thought cover reflux, cover distillation, cover the purification of the solid. There's a good chance something will come up. Everyone's happy? Everyone's happy there? Ollie's happy. It's good to hear. Pax is not happy. Or maybe he is. Realistically, he just plugged something wrong in the calculator. As long as you would get all the method marks, I'm almost 100% sure. And obviously, we are in a live. It's 8 in the evening. I'm not doing paper 3 chemistry. I'm going to do videos for it, but I'm not going to do a live stream. This is my last live stream, guys. Last live stream. I do hope you guys. Obviously, you've done most of your exams already, but I do hope they've all gone very well. So from here, I've seen people are happy. Let's put on the next question, guys. It's a rigid body question. Plug wrong. Yeah, it's just little calculator values. It's the evening before your exam. You've been revising all day. I would not stress about plugging stuff wrong in the calculator at all. You get given a quarter. They told you that mu equals a quarter in the question. We have a rigid body question, guys. Rigid body. We know we're going to be finding moments. We know we're going to be resolving horizontally. And we know we're going to be resolving vertically. Okay, we know we're going to be doing these three things in every rigid body question. It's disgusting, it's repetitive, but the tricky part is to label the forces. I think I did that a much more complicated way, but I got 93.2 still. as long as you got the right answer, right? So that matters. Gonna leave this up for just a second. Bit of a hinge question. This time, guys, let's start covering these forces. Actually, I'll do the forces at the end. I'll do the forces at the end. I'll just cover the question first, okay? I think that'd be the best way to do it. Okay, let's go. Let's go, guys. It's probably gonna be till 10 o'clock this stream, maybe 9:45. We'll see how long this takes. Might take a while. Okay, let's go OneNotes actually. What back to OneNotes. Alrighty, nah, that's this one, sorry. Alright, let's go. Okay. So the uniform, a lot of waffle guys, it's mechanics. The uniform rod AB is uniform, of length 1.5 meters, and has mass 3 kilograms. Is smoothly hinged, so we don't have friction, to a vertical wall at point A. The rod is held in equilibrium in a horizontal position by a light strut CD, so we can see CD here, where we, as shown in the diagram above. The rod and the strut lie in the same vertical plane, okay, good, which is perpendicular to the wall. Bit of waffle there. The end C of the strut is freely jointed to the wall at a point 0.5 meters vertically below A. So it's just what we're seeing. The ND is freely joined to the rod, so the AD is 0.5 meters. Okay, find the thrust in D. Hardest part of this question, guys. Let's put on all the forces onto our force diagram. You know I'm gonna have to do it with it already filled in, but let's go. So we have a smooth wall. Guys. However, it is a hinge. Okay? When we have a hinge, it doesn't matter whether there's friction or not. If it's a hinge, there is going to be that vertical component and there is going to be a horizontal component. Okay? Think about it like this, guys. With this one here, where CD is thrusting, if it was roughly hinged, which way would friction act? Okay? With this, don't worry. Here's the thing, guys. It's not going to be roughly hinged. If it's roughly hinged, you put that force the same as you would before. Same as you would before. It doesn't matter if you put it up or down, because remember, it can either be up in this case, so it can be up if the weight or whatever's on our platform here is, let's say a man stands on it or is really, really heavy, then your hinge would have to be going upwards. Yeah, whether it's rough or not. But the thing is, it won't be rough. It won't be rough because the hinge implies that you have that vertical and horizontal force. Yeah, when we don't have a hinge, when it's just the beam on the wall, it has to be a rough wall. Otherwise, it would just slip down, right? It would just slip down. That's what it's trying to do. Okay, so if there's no hinge, it's going to be rough. Otherwise, it would make no sense. And if we do have a hinge, then we don't need to imply rough or smooth. Okay, because that hinge is going to have to apply forces. If they say rough with a hinge, which I don't think they can, it doesn't make any sense because that hinge already implies you have those forces. You just solve it normally. And it doesn't matter what direction you put it, because if your answer is negative, it would have been in the other direction. Okay? If you get a negative value for that force, it would have been in the other direction. Okay? I hope that makes sense. It can be either way, because you could either have it that this force from CD, for example, is pushing it so far up, like pushing it really, it's really tight or something, that your hinge needs to try and bring this back down. Okay? Or we could have something, or this could be really heavy, it could be a shelf, for example, or you could have something like a man standing on the shelf trying to push it down, then it's gonna have to go vertically. So it could be either way. Oh, sorry, yeah, the question. Find the thrust in CD for part A. The reason why with these I'm not so bothered about the question is because it's always the same thing. Moments, vertical, horizontal. Yeah, you're always going to do those three things. Normally the moments will be first because you want to eliminate unknown forces. So let's go through the forces step by step. I hope, guys, give me a thumbs up if those make sense. I'm going to go through all of the forces at the end of these questions. Okay? Let's go through. Uniform rod, length 1.5, mass G. Straight away, what do we know, guys? We're going to have this 3G in the center of our rod, so it's going to be 0.75. So in the middle, halfway from A to B, right? It's going to be 0.75 from A and 0.75 from B. We're going to force 3G going down. We know that already. What else do we know? We know at our hinge A, our hinge, the whole point of a hinge is it's going to support, in this case, we have a rod. It's going to support our rod by either. So guys, why is the X value going inwards? Why is the X value going inwards? Let's think about it. Because this CD thing is pushing, if we think about the horizontal component, it's pushing it outwards. Our hinge is going to have to keep it attached to the wall by pushing inwards. So we have something pushing outwards and we have to keep it going inwards. On the contrary, earlier today when we looked at the 2018 hinge question, guys, where we had a rope pulling it inwards, putting it inwards, guys. In this case, the hinge, or this might have been the rough wall. Exactly. When it's not a hinge, it's going to be the rough wall. But either way, that horizontal force, that reaction force, in that case, because we were putting it inwards, had to be going outwards, right? So in this case, we're thrusting it outwards, so our hinge has to be putting it inwards. In that case, when we were thrusting it inwards, our hinge had to be pulling it up, pushing it outwards. We want them to be balanced. So that's how you determine the reaction force. Okay, that's the best way to think of it. These are the only two ways you can get these hinge questions or rough wall questions. It will either be hinge or rough wall. Okay, you can't have neither, otherwise it's just going to fall down like this, right? It wouldn't make sense. I mean, they can't ask you that. It wouldn't make any sense. So continuing on, let's go through the forces. I hope this is helpful, guys. Thumbs up if this is helpful. Smash subscribe. So what we thinking? What else do we have? Okay. So smoothly hinged, we established that we're gonna have it going away because our thrust is pushing it outwards, so we're gonna have to have something pushing it inwards. Okay. Once again, it does not matter which way y will be. We can imagine we're gonna guess that it's gonna be downwards. Why are we gonna guess that it's gonna be downwards? Because our thrust is pushing it like upwards, right? Because it's going upwards diagonally. So we can guess that our hinge is going to have to push it downwards to counteract. Once again, it does not matter if you get that part wrong because you'll find out at the end if you get a negative value. So do not stress about that. So where were we? Where were we? I think that's all of our forces, right? Perpendicular to the wall. So we have our x, we have our y. We labeled this the tension, I guess. What do they call it? What do they call it? Like strut, yeah, but it's still that force of that strut. Remember, guys, this force is not at D. It's not a reaction force. Do not get this mixed up with ladder questions where you have like a peg or a ball or something. This force goes all the way up like this. You can always extend these forces, whether it's a rope or a strut or whatever other word they use. Yeah, it's not a reaction force at D. This is just an ongoing rotational force. Okay. Why are they equal to each other? Can you upload this file on your link tree after? Would love to try these questions in the morning. Yeah, I will. Will do that. Pax was a question. Why are they equal to each other? Why are they equal to each other? What's equal, sorry? Because we're in equilibrium. That shelf is being held, right? So whatever's pushing outwards must be matched by whatever's pushing inwards, and whatever's pushing down or up will have to be matched by the hinge counteracting that force. Otherwise, our shelf will go bang or up or like that or like that. It has to be balanced, yeah. In this case, it's a rod, but try think of it as a shelf that could help, yeah. Just think of the real world. If you have to look, isn't the tension basically the thrust? Exactly, yeah, exactly. In CD, isn't the tension basically the thrust? Yeah, exactly that. Exactly that. It's the same thing. Tension in the rope is like the thrust in CD. Same idea. So let's go through the question. I just really want to make this clear, guys. I want to make this very, very clear. Moments at A, are they not both moving in the same direction? The moments of A. So what do we have for the moments of A? We have moments around A. There's two things. We have T, which will be taking. Let's go through the question because this is already going through the question. Okay. So going through, guys, we're gonna find the moments at A, right? So what do we have? So first things first, we have perpendicular distance times the force. Sorry, mine went blank for a second. Perpendicular distance times the force. So that's 0.5, 0.25. We're going to have that's part of the question for me, clockwise moment. We have a clockwise moment. So we're going clockwise. This is going to be our 3g, right? That's going to be a clockwise moment. What is the perpendicular distance from A? Why are we taking moments about A? Because we want to get rid of this x and this y, which are unknown. So perpendicular distance from A is going to be 0.75. So we have 0.75 times 3g. And then the anti-clockwise moment, taking us the other way, will be this force T. If we want to, I probably should have done a different color. And the anti-clockwise moment, taking us the other way, trying to rotate us out this way. So that's the anti-clockwise. Are we happy with that, Pax? Let me know if that makes sense. It's going to be this force and the perpendicular distance to A. Perpendicular distance, guys, remember, shortest possible distance will be here. Think of this T line. Let's clear this up, make it look a little bit nicer. Think of this T line as all the way extended out. The shortest possible distance. I think Neil does maths like this. When I did my A levels, he was always saying, use a ruler, and like see the shortest possible distance. You can clearly see the shortest possible distance is going to be here, right? So we have to find that distance. How do we find that distance? They give you the information that we have 0.5 and 0.5 meters, as I said in the question, 0.5, 0.5 meters. We have an isosceles triangle, okay? Exactly, yeah, perfect, yes, yeah. We have the isosceles triangle. This is going to be 90. If this is 90, and we know isosceles, these two angles are the same. Angles inside a triangle add up to 180. Therefore, these have to both be 45. Okay, we want to find this distance. Now, we can use either kind of angle here, either side, because we care about either sine 45 or cos 45, right? Those are the two that we care about. Let's draw it on, not in a highlighter, let's draw it on like this. Make it a little bit clearer. So our hypotenuse is 0.5. Hypotenuse is 0.5. So this, if we're using this angle, for example, because remember, we're thinking about it's either going to be cos 45 or sine 45, right? But we don't care. We all good? We all good? Yeah, okay. Anyway, let's just use this angle to make it a little bit easier. So we have our perpendicular distance to be here. We have the hypotenuse. It's going to be the hypotenuse. Here's the opposite. We know that the opposite over the hypotenuse is sine 45. Therefore, the opposite multiplied through by the hypotenuse is going to be 0.5 sine 45. So that's where we get that from. And the force will be T. So our force is T. We found the perpendicular distance using this isosceles triangle. Amazing. 0.75 times 3g will be equal to T times 0.5 sine 45. Okay? Sine 45 is root 2 over 2. Times that by a half is going to be root 2 over 4 times T. And then we have 0.75 times 3g is 9 over 4g. Okay? What do they want? What do they want? The thrust in D? The thrust in D, sorry, is just that T. And CD is just that T. Okay? So T will be equal to, all we have to do, divide over by root 2 over 4. So you can multiply by 4, divide by root 2, whatever you want, however you want to think of it, guys, doesn't matter, equals 9 over root 2g. This will give us 62.366 bunch of decimal places. This is mechanics, we do 3 significant figures. So this is 62.4 newtons. Thumbs up if that makes sense, guys. Why are we allowed to use a triangle? I thought opposing force had to be upwards strictly. Why are we allowed to use that triangle? I thought the opposing force had to be upwards strictly to oppose 0.75 times 3g. No. Sorry, I shouldn't say it like that. But no, as long as we're working oh my days. What am I doing? So as long as we're working the anti-clockwise and that clockwise, we're not resolving horizontally or vertically. All we're doing is finding the moments, right? So all we care about is a clockwise or an anti-clockwise moment. Okay, they don't need to be parallel to each other. It's not like when we have the particle where they're parallel and both perpendicular to the plane. In this case, we just care about one rotating it that way and the other rotating it that way. Okay? It's the same idea with the rope, guys. I'm going to keep comparing it to the other question. Same idea for the rope, wherever it is. Clockwise moment will be was going this way, but then our rope tension here, our anti-clockwise moment was going this way. Okay, it's the same idea. Same idea. They don't need to be. They do not need to be both vertical and both horizontal. That is if we're going vertical and horizontal, but not when we're doing moments. So let's carry on with this question, guys. There is actually a second part to this question. Find the magnitude. Okay, find the magnitude and the direction of the force exerted on the rod AB at A. You wish exam was in the morning? Really? Damn. I know most people don't like the morning. But let's do part B. They want the magnitude and direction of the force exerted on the rod at AB. So what do we care about? What do we care about? The magnitude of the force. This is basically saying, like we do in all these questions, they now want us to find X and Y. Okay? You guys prefer the morning, fair enough. So we have our T to be 9 over root 2G. What do we do in rigid bodies questions? The same thing all the time. Is painful. Now that we've done the hard bit, horizontal, vertical. Yeah? Horizontal and vertical, guys. Horizontal and vertical. We know we're going to split our T force. This is where it matters about horizontal and vertical. This is split our T force into the horizontal and into vertical components. Okay? So now we care about that. Oh, what am I doing? Okay, there we go. So we know our vertical component, because this angle will be 45, is going to be T sine 45, because this makes a 90-degree angle. This is going to be 45. You can draw it out however you want. You could even draw this 45 going vertically up here, and it would still give you that T sine 45. Once again, it doesn't matter whether it's sine 45 or cos 45, because they both give you root 2 over 2. So no matter how you draw this, and if you've got the other value, you would still get the right answer in this question. Okay, for the vertical, being opposite to this angle, it's going to be T sine 45, and then the horizontal is going to be T cos 45. Now we care about the horizontal equals the vertical. Resolving horizontally, what do we have? So X is taking us to the left, what is taking us to the right? T cos 45. So therefore, we know the value of T is 9 over root 2G. Cos 45 is root 2 over 2. Put it in the calculator, we get that X equals 44.1 newtons. Okay, great, we have X already. Let's find Y. For Y, we're going to resolve vertically now. So we have that y plus 3g, those are both going down, will be equal to t sine 45. Why are they equal? Because our was it shelf, rod, whatever it is not moving. It's in stable equilibrium. Okay. So y plus 3g equals t sine 45. We know t is 9 over root 2g, then 3g. So we have 9 over root 2g times by root 2 over 2. That's sine 45. Take away 3g to get y. Okay, so y equals 14.7 newtons. This is great. We got a positive value for y, so our y is going downwards. If we put it upwards, we would get minus 14.7, and we would know it would be going downwards. Okay, find x and y and then square root. Perfect packs. We found x, we found y. We also need the direction though. We found x, we found y. Good way to think of it is set up your little triangle like this. First of all, find the magnitude. We do 14.7 squared plus 44.1 squared. It's like when we're trying to find the speed with velocities or any other magnitude question, really. Take the square root, we get 46.5 newtons to be the magnitude. Now to find the direction, we want to find theta here. So we do our opposite over our adjacent. So tan theta is y over x. Therefore, just theta will be equal to the inverse of tan of our vertical, which is 14.7 over 44.1. So that's 18.4. Keep in mind, guys, that 18.4, normally they will ask you like relative to which plane. This question's a little bit ambiguous, but that 18.4 would be this angle here, right? It's this angle here if we went this way. 18.4 below the line BA. If we were going from B to A, it would be below that line. Okay, or anti-clockwise, you could say. But they would ask you if they want the angle, they'd be very specific in the question about where they want the angle from. Because you may have to do 180 minus your answer, for example. Something like that. Guys, are we feeling more confident about forces? Oh yeah, exactly. It wouldn't even matter because your negative would become positive when you square it. How do you know which way tension is acting? Tension, tension. You want the tension. Um, tension. The tension in this question is going to be pushing upwards into your cupboard, or a cupboard into your shelf or rod or whatever it is. It's pushing upwards. If it was a rope, once again, I'm going to keep showing you these two hinge questions because you will get one of these two questions. If it was a rope, you're pulling up. If you're a new viewer, then let me know. But we did just go over it, so you can rewind a bit if you want. And I just explained it all. Acts towards rod. Yeah, in this case, because we're thrusting into that rod, we're going to be acting towards it. If we were a rope pulling the rod upwards, we'd be pulling it kind of away, right? Hope that guys, are we happy now with these hinges and rough walls and stuff for this hinge kind of question? For a ladder, guys, for a ladder, we're going to do a ladder question now. So I'm going to specify the ladder stuff as well. Yeah. Guys, let me know if we're happy about all this hinge stuff and everything like that. I've tried my best to explain it. If you want me to go over it again, I will. But I feel like that kind of clears some stuff up. One last question, guys. I do actually have a geography section as well, which is just like all the memory stuff. But I wouldn't stress too much about that. What is alpha? Right, guys. One last question. What is alpha? Alpha where? What phi? Okay, let's go. Last question of the day, guys. Then I will put up the geography stuff. The last question of the day. Last question of the day. Another rigid body. I want you guys to be really comfortable with whatever rigid body comes up. Okay. So let's go. The figure above. Wait, let me make sure the stream isn't like crashing or anything like that. Make sure we're all good. We are all good. Okay. What is alpha from the last question? This 18.4 is the angle going downwards from AB. 18.4. Are we happy? Fat packs, are you happy? 18.4, the angle size for that tan of theta to be y over x. I'm gonna carry on, but like, let me know if there's a thumbs down or anything. Okay. Okay. So the figure above shows ladder AB. Let's do this in OneNote. The figure above shows ladder AB. Yes, perfect. Okay, cool. Resting in equilibrium with one end on A, with one end A on rough horizontal ground. Rough horizontal ground, guys. Tell me which way there's going to be friction. It's rough. Tell me which way that friction is going to be going as I read the rest. And the other end B on a smooth vertical wall. If we have a ladder resting on a smooth vertical wall, there's going to be no vertical forces. Yeah, no friction, nothing like that. The only thing we will get, as always, is that reaction force. Because you're resting on the wall, that wall is going to be giving a reaction force. Otherwise, you just go through the wall, I guess, right? But because it's smooth, there's not going to be any vertical forces. Yep, friction is going left, exactly that. Because why? Why is it going left? Because that ladder is trying to slide downwards. When you see someone fall off a ladder, the ladder tries to go like this. So the friction needs to be pulling it this way to prevent that ladder from falling down. Yep, Oscar's happy, Yusuf's happy, everyone's happy. Okay, cool. So rough horizontal ground, the other end of the smooth vertical wall. The ladder is modeled as a uniform rod, so the center of mass will be in the center, right halfway of the length, 5 meters and mass of 20 kg. We're going to start labeling this stuff on, guys. Analyzing a vertical plane perpendicular to the wall and the ground, perfect. Inclined at angle phi, they'll probably give you alpha or theta in the exam, to the horizontal. When a person, which is modeled as a particle of mass 60 kg, stands at point C on the ladder, okay, they tell us the distance, which is quite friendly of them. AC is 4, so it's like up here, guys. Person's going to stand of 60 kg. The ladder is at the point of slipping. What does slipping mean? We've done it already a lot of times, this question. What does slipping mean? I want you guys to say it again. Your exam's tomorrow. Doesn't hurt. For the point of slipping, what does that mean? Okay, given the coefficient of friction between the ground and the ladder and the ground is a quarter, find the magnitude of the frictional force of the ground on the ladder. Okay, and the value of phi to the nearest degree. Okay, so let's label our forces. First of all, let's go one by one. So as we know, one end is on A on rough horizontal ground. Limiting equilibrium, yeah, friction will be at its maximum mu times R. Perfect. So what do we have? We're slipping, so our friction is going to be max mu times R. Exactly that. What do we know? Let's go step by step. Rough ground. We have our reaction force from the ground, as always. And because it's rough, we're also going to have that friction. Because it is, was the end of slipping or something? Because it was slipping, it's going to be mu times R. What do we have? A mass of 20 kilograms on a uniform rod. So 2.5 up, halfway. It's the whole thing is 5 meters, so halfway up is going to be 2.5. So we have 20 G going down. Perfect. What else do we know? What else do we know? We're going to have that reaction force at point B. It's not a rough wall, so there's not going to be anything going up or down here. So no stressing about that. Nothing like that. Nothing like that. Continuing, inclined at angle phi. The person of 60 kilograms is 4 meters away from A. Okay, so 2.5 plus 1.5 is 4. So we're going to have the 60 G going down here. Perfect. Why is there a reaction force at B when it's a smooth wall? It's a smooth wall, so we're not going to have any friction. But what is friction? Friction is saying our ladder is resting on that wall and there's no friction. There's nothing preventing it from sliding down on the wall. However, because you're not going through the wall, that wall is still supporting that with a reaction force. Your ladder is on the wall. What is that ladder feeling? We know it's not feeling anything that's preventing it from going down, but we do know it's preventing it from going through the wall. Yeah, Oscar's got it. Perfect. Hope that helps. So where were we? Where were we? We have mu equals a quarter. We have to find the magnitude of the frictional force of the ground on the ladder. Okay? As always, guys, we're going to find moments. All right? Why do we find moments? To get rid of this mu r and the r. Okay? I'm not sure it's 1 mark. Either way. Okay. That's your frictional force on the ground on the ladder. So what we're going to do, we're going to find moments about A because we have 2 unknowns here. We don't know these unknowns. So let's go moments about A. Moments about A, what do we have? We have a clockwise. So that's right. Yeah, clockwise here. Pulling our ladder clockwise is that reaction force N. And then going anti-clockwise, we have this 20G and this 60G. I'm not sure how Neil does this for 12 hours, guys. Fair enough to him. Okay, you guys quick. Let's quickly go through this then. Okay, we're happy with this. Moments about A. The anti-clockwise moments. What is the distance from them? Sorry. So it's going to be which distance do we care about? The perpendicular distance. We care about this distance. We have our hypotenuse. We have our angle. We care about the adjacent. So it's going to be 2.5 cos phi times 20G. Same idea with the 60G. It's going to be 4 as our total distance. So distance times perpendicular. Sorry, force times perpendicular distance. 60 times, in this case, it's going to be 4 cos phi. And then we have this will be equal to perpendicular distance to N will be up here, or I guess you could think of it as up here. Either way, it's the same perpendicular distance. That is going to be, because remember guys, we can extend this force out. It's just going to be N times 5 sine alpha. Why is it 5? Because the whole distance of our hypotenuse is 5. Okay, nothing too tricky there. So we have 50G cos phi plus 40G cos phi equals 5n times sine phi. We can't do more at this point, so we're going to resolve horizontally and resolve vertically. Resolving horizontally, we have that mu times r equals, right, horizontally, we have this going to the left, this going to the right, nothing else. So mu times r equals n. Then resolving vertically, 60g plus 20g will be equal to our reaction force. So r equals 80g, this is great, we have r. So we can plug this in, we have the n equals mu times r, I believe, and n equals mu times r, we have r, and we have mu as well, guys, because mu is a quarter, they tell us in the question. So n equals a quarter times 80g, therefore our n value is 20g. 80 times a quarter is 20g. This is 196 newtons, but don't worry too much from that. So magnitude of frictional force of the ground on the ladder. Okay, let's just continue on, guys. Let's continue on. And then we want to find the value of the angle. Okay. I don't even know if I answered the question. I remember I just wanted to do this just to be clear, but just show you guys it's always the same thing. Where were we? So mu times I equals n. Okay, fine. And then okay, fine. Yeah. So we are already answered the question. So now we're going to use this value of n to find the angle. So to use this n, we have that 50g cos phi, looking at our equation from before, 50g cos phi, our moment's equation, plus 240g cos phi equals 5 psi 20g. Okay? Because we now know that n is 20g. So from here, 50g cos phi plus 240g cos phi, this is 295 295g cos phi. Sorry, 290g cos phi, sorry guys, equals 100g sin phi. My brain is slowing down already. Now what we can do, we can divide both sides by g, divide both sides by 10, so we have 29 cos phi equals 10 sin phi. From here, we can divide over by 10, divide over by cos phi, so we get that tan phi, equals 29 over 10. I don't think I even answered part A. What did they want for our part A? The magnitude of the frictional force of the ground on the ladder. So that's mu times r. So that's a quarter times by 80g. It's just 20g, right? Am I going wrong? My angle is 71, but I reckon I'm missing. Yeah. 71, yeah, everyone's happy with the angle. So I remember when I was doing this question, I was just trying to find the angle. Didn't really care about the part A because it was just a one marker. But yeah, guys, are we happy with all of the forces, like hinges and everything like that? You guys seem pretty happy with these answers. I hope that was all good. Hope we're all happy with that, guys. Checking the stream. Yeah, we're still on. We're still on. The laptop is surviving. Hey guys, my brain is starting to slow down already. Only only 2 hours. I don't know how Neil does it for 12. Fair enough to Neil. Right, guys. So gotta rest up for your exam. I'm gonna just leave this up on the board. Large data set, guys. May to October 87 to 2015. Oscar's very happy. That's what we like to hear. Everyone's happy. Everyone's happy. Boys, it's the last maths exam tomorrow. I'm gonna leave up this just for a second. Remember as well, guys, they do like to use this large data set stuff for discrete. You know the 2080, where does it say A is, where did R come from? Think I missed something. Yeah, okay. So was just simply our reaction force. R was just the reaction force from the ground onto the ladder. Okay, and then we know because friction, or because we're on the point of slipping, friction is mu times R. And then what we did was resolve horizontally, which is mu times R equals n, and then we resolve vertically. Same thing as always. R is just the reaction force. Yeah, guys, I need to buy an Apple pen. This is the horrible. This is really horrible. So what are we saying? Where does it say it's smoothly hinged? 2018, 2018. No, no, no. Here's the thing. With 2018, we're not actually hinged, right? This is what I was saying before. You're either going to be hinged or it's going to be a rough wall. Yeah. Either way, the friction force will be either one. Sorry, the friction force, you just replace your Y as friction. Okay? Guys, yeah, I appreciate that. But it's not, it doesn't actually say hinged anywhere, unless I'm wrong. It might say hinged. Plank AB of mass M, length 2A, and horizontal position when represented, the momentum touch the wall. Small block of mass 3M is placed on the plank. Plank is in equilibrium. It doesn't say hinged, right? So this makes sense. Because there is no hinge, we know a hinge is what keeps it in place, right? There is no hinge. The only way that we can be kept in place, given there's no hinge, so otherwise we'd just be going down like this. The only way that we can be kept in place, given no hinge, is if we have a rough wall, right? Otherwise, it's a rough wall, we're going to have friction preventing our, let's call it a shelf, from going down. Fred, are we happy with all the forces? I know Fred asked me a question earlier. I feel like I've explained everything I can with the ladders, the hinges. Oh, so it would always have two forces. If it's a hinge question, yes. If it's a hinge question, because you're either going to be thrusting away, so therefore you're going to have to be pulling it inwards, or you're going to be pulling it towards, so you're going to have that reaction force going outwards. Then naturally you have to have one going up and one going down to prevent it from falling. If it's a hinge, yeah, hinge and rough wall. Because if rough wall, you're going to need to prevent it from either falling or going upwards, either way. And if it's a hinge, the whole point of a hinge is so that I'm not trying to sound obvious here. I'm just trying to like explain this carefully. The whole point of a hinge is to make sure that we're not slipping down. It's fixing it in that position. I hope that makes sense, guys. Okay, cool. Fred's happy. Fred's happy. Could you zoom out? Oh, this is the 2018 question, guys. This is a 2018 question. I just thought it was a the two hinge questions you can get are either the thrust or the pulling of the rope. But here's the thing, they might not even come up. We're doing all this practice. I think in 2024 it was just a peg in the end, and I think it was a smooth peg, so that was nothing bad either. But yeah, this is a 2018 question, so I'm gonna move on from it. Um, yeah, this large data set stuff. Know your know your what's it called units. Know whether it's discrete or continuous. So, for example, one thing that they do like to do was the cloud cover. I believe it was in a past paper. It's in octets, so you can even have 0, 1, 2, all the way up to nine, oh, up to 8. Sorry, so you have 9 different options. They could ask you to do a discrete probability distribution table with any of these discrete random variables, like cloud cover. And for example, if they ask you, or if they tell you there's equal probability, like the cloud cover questions, each one will have probability 1/9 because there are 9 options: 0, 1, 2, 3, 4, all the way to 8. I hope that makes sense, guys. We're going to end at 10 o'clock. If it's a rough peg, would there be two reactions? If it's a rough peg, then you're going to have friction from that peg. The friction will be going upwards, right? Because think about it, your ladder's on a peg. It's not going to be moving upwards, is it? It's trying to move down. The ladder's trying to move down if you're on that slope. So if you had a rough peg, you'd be having friction pushing up from that peg as well as that reaction force from your peg. Showering and calling it a day. Yeah, you got time, guys. Do you guys have any topic recommendations for tomorrow morning? I'm going to do a post tomorrow. I'm going to post a very simple normal hypothesis test tonight, and then I'm going to post again tomorrow. Is there any mechanics or stats topics you want? I'll find the hardest question possible. I've got time in the morning, so no, we can't wash this knowledge away. Yeah, you can't be showering. Can't be showering now. Got to keep everything in your head. Last speech, boys. You've done paper one. You've done paper two. They've screwed you over for paper two. They gave you topics that you would never have imagined. I don't care what people say. Predicted papers should be helpful. They should test you on what you know. But we know with paper three, you guys know everything. You've done every single question. You're so prepared. You're motivated. You've been showing up to every single stream. You don't need me to give you a speech because you guys have that determination. You guys are going to be fine. You guys are going to be absolutely fine. Normal approximation, difficult question. Hard histogram, discrete. Neil does maths. You know what I can do? I can, because the thing is with stats and mechanics, like half the time I just change the numbers of the question because you can just do that because they repeat very similar questions in general. So what I'm gonna do, I'll find that normal approximation question, and then I'll just kind of like mix up the numbers potentially, make it a little bit different. But yeah, that's it, guys. I hope these streams will be helpful. I wish you the best of luck. Please message me what you guys get in your exam, because I'm sure you're all gonna do really well. But yeah, I think that is it. Just gonna see if there's any last questions. Yeah, giving you a pep talk. Yeah, boys, I had to give some motivation, right? Last maths exam. I'm calling it a day after today, so for me, this is the last stream for me. I wish you guys the best of luck. Smash like, smash subscribe, and good luck for your exam tomorrow, guys. I appreciate all the support. I really do. Cheers, guys.